All right. Hi, everyone. I've given this talk a lot. It's my favorite talk because of the implications it can have on the community and especially in this field. But my name's Samuel Wyatt. I'm a support scientist at NASA. I actually spend most of my time doing what Jamie talked about this morning, working on the Across project for all the subsequent NASA missions, but I'm very grateful that they still let me work on the treasure map. So here's our team. It's been roughly the same for the past, I don't know, 6 years or so. For NASA now, we consider ourselves a worldwide collaboration, working from Israel, Canada, and California. The motivations. So if we want to comprehensively study EM counterparts, the main goal is we need to efficiently find them first. And so with that, I would say the discovery is key. And so what does it look like when we're trying to find counterparts to gravitational wave events? There are essentially two scenarios, and they can play out in multiple ways. Teams, they either tile the gravitational wave probability maps, or they can look at galaxies within those regions at which they think they might contain the counterpart or the origination of the gravitational wave event. And so what often happens is essentially the second scenario where everyone just looks in the most probable regions at first, whereas the optimal scenario where teams they communicate with each other and through passive or actual collaboration say, hey, I'm going to look here. You also can look around where I'm going to look and complement our searches in the same time and optimize how they're going to find the counterparts. And so what this brings is that there's a subsequent need for a service that can host observation strategies. They can offer observing strategies tools. What has been observed? Where's the most optimal area at which we can look in at this time? And in consequence, it will be able to enable real-time observing collaboration between all teams within any instruments. And so what do? We built this web application called the Gravitational Wave Treasure Map. At first order, it's a web interface with a RESTful API where users can programmatically submit and query their observation strategies when it comes to any non-localized event. Right now, we just center on gravitational waves, but in the future, we're also going to host potentially like neutrino events as well. And so there are web pages associated with, there's neat visualization. The visualization is just a hook to get users in. It's nice to see where everyone's looking, but I think the real meat is in the API where it's fully documented. I take suggestions. I'm pretty much the core developer on it. And I just recently published an API wrapper in Python, which has tools built upon it. And so, like I said, the ultimate strength is that you have the ability to get, post, fully RESTful. We don't allow deleting because it's a consequence of the data. So you can get, post, update your pointings. You can get DOIs associated with your pointings. I know that was something that was brought up yesterday, like how can users, what is the incentive to looking in the least probable areas? We can provide some sort of citable interface to where you can essentially get credit for not finding it or even finding it if you look in the least probable areas. You can also, there's a lot of other tools built on top of it. You can post candidates that are associated with the gravitational wave event. You can update them. You can post convolved galaxies. So these galaxies that your pointed searches are going to look for these areas. And ultimately, everything is fully documented with Python tutorials. Here's an example of the visualization. It's interactive, it's built on Aladdin, it's super fun, and I think it makes these kind of events really easy to access and assess where everyone is looking. You can toggle the contours, the footprints, you can filter the pointings, and you can overlay source information, the galaxies. We just started recently ingesting the ice cube coincident alerts as well, and you can also post candidates. Here's an example of the galaxies. You can view them, zoom in on them, click on them, get information based on what the user posts. Here's an example of the ice cube alerts where you get pretty much a circular region that's coincident with the higher probability areas of the gravitational wave event. There's no API endpoints for getting them soon, but they could come soon. Here's the counterpart candidates. Again, you can just visualize where people think there might be an associated gravitational wave counterpart source, and see that in the visualization as well. There are tools built on top of it, accessible through the webpage. There's a coverage calculator where you can assess like how much of the probability has been covered. You can filter based on pointings, say I want to get everything that has observed this and look for the gravitational wave counterpart down to a certain magnitude at a certain band, and you can see how efficiently it's been observed and follow it up. And validation, like I mentioned, we can give Zenodo DOIs for all of the pointings that you submit to efficiently give you incentivize effort for covering the lower probability areas. And so that if something is found, it also provides incentive for other people to be like, I looked in this area because I know someone else had already looked there. And so you can cite that in a GCN or a paper themselves. And so, like this was brought up today, there was pretty much one interesting event that has happened so far in 04 that has been really well covered. And it was in April. Within the first 5 days, there was 2,200 completed pointings submitted to the treasure map. Within the first 6 hours, 70% had been covered to a depth of 20.5 magnitude in an arbitrary band. I don't know which one. And 90% of the probability area was covered in the first 24 hours. And the thing I want to highlight that these all were posted in near real time. So teams are utilizing the treasure map within the days or of the events happening, which is exciting. The current work, like I mentioned right now, we're working on an API wrapper. The meat of this and like the motivation behind this is that I wanted to take a lot of the weightlifting off of the website itself and provide client tools that only utilize the data. And so right now there's tools to create your own visualizations based off of pointings that you want to see. You can do the coverage calculator. You can do map renormalization, which essentially is like, I have this list of pointings. I know they didn't find anything. And so I want to recreate the HealPix map and put that into my own scheduler to essentially look where everyone else hasn't. And also there's candidate coverage. So if we're given a list of candidates, you can find the instruments that have already covered them. So if a candidate gets submitted, you can say like, oh, these instruments may have seen them as well. And so some sort of functionality that I should try to think of, be like, this would be useful for someone. But the main thing is that if you have a suggestion for treasure map data and you want to implement into this API wrapper, I am more than welcome to do that. Take some time out and help the community. And like future implementations, we want to do schedule suggestions. So there was a talk earlier today about TilePy. I can see something like the treasure map tying really well into that, where a user who does search and tile for gravitational wave events can get a list of suggested observations based off of potentially a map renormalization. And then subsequent work will be supporting candidate follow-up. So potential like target pages for photometry and spectroscopy for these potential candidates. And again, like I mentioned, I'm very open for feature suggestions. And so I want to end on highlighting a paper that came out earlier this year, where Ido Kainen and Yair wrote a paper on whether or not an event in 03 could have been detected if coordination had been established efficiently. And one thing that they highlight is that 75% of the localization region was accessible at the time when the event happened. There were enough observational resources invested to the accessible part for 90% of the probability region to be covered within the first hours of the event. And what actually happened is that everyone tiled the highest probability region hundreds of times. And what they urge at the end of this is that, well, what they did is that they utilized all pretty much mostly open source data, mostly treasure map data for all the completed pointings for this event, and performed all of this analysis and said that if you had looked earlier, you potentially could have discovered something, but everyone looked at the exact same areas over and over again and didn't find it. And one thing that they found is that if it was like a 0817 event kilonova, it could have been 3 to 4 times the magnitude fainter at its peak, and we still could have found it, but we didn't. So conclusions are this utility is only strong as those who use it and those who choose to submit their data to it. But highlights is that observing strategies are being ingested in real time in the O4. So hopefully we do have more interesting events. Any questions?